Alright, so this lesson is going to have a little bit to deal with inequalities. So what I want you to do is kind of refresh yourself with your algebra skills on inequalities. And I've got 18 problems here. I don't want you to do all of those. I just want you to do the odd problems. So pause the video, try out the first couple odd problems, and if you feel like you're struggling there, then watch the next part of the video and I'll go over a couple of these questions. So number one on the warm-up is 7x minus 13 is less than or equal to negative 20. We're going to pretend like that inequality here. We call it an inequality because I'm saying that the two sides are either not equal or one side can be less than the other. So in this case I'm saying this side is less than or equal to negative 20. So I'm just going to treat it like an equal sign when I solve it, with the exception of when you multiply or divide both sides by a negative. If you multiply or divide both sides by a negative number, then you flip that sign. And remember what we mean by this. This is saying that whatever the open end here is, it's pointing towards the greater side. So this is 7x minus 13 is less than or equal to, because it has this bar here, to negative 20. So to solve for this, I'm going to add 13 to both sides. And these will cancel, and this gives me negative 7. 7x right here. Divide both sides by 7. Now just because there's a negative in the problem doesn't mean we have to flip the sign. It's if we're dividing by a negative. Here I'm not dividing by a negative, I'm dividing by a positive 7. So I don't flip the sign. And this is x is less than or equal to negative 1. And if you were to check this, if you put negative 1 in, what do we get? Well, we get negative 7 minus 13, which equals a negative 20. Is negative 20 less than or equal to negative 20? It is. In fact, it's equal to it. Our solutions, if we were to graph them, if I can draw a straight line, let me try this again. Not straight, but try to get it to us as a slope of 0. Here's my number line. At negative 1, I would say, okay, we're going to include that negative 1, so fill it in solid. And it's any number that goes less than that will make this inequality a true statement. For instance, if we were to pick negative 5 is less than negative 1. So if you put negative 5 in, you're going to get negative 35 minus 13, and that should be less than or equal to negative 20, which gives you negative 48, and that is less than or equal to negative 20, so that works. So there's an infinite amount of solutions here, but they're all going to be less than or equal to negative 1. So this inequality is my answer. I can't list all the possible values for x. It's going to be anything less than or equal to negative 1. Let's try another one. So for this one, I'm going to add 5 to both sides. That gives me negative 2x is less than, was it 21? And dividing by 2, I get x is less than dividing by negative 2, right? So be careful there. When we divide by negative, we've got to flip that sign. So flipping the sign makes it x is greater than. And this is going to be negative 10.5. So any number bigger than negative 10.5 will make this work. If it's equal to negative 10.5, then I get positive 21 right here, and 21 minus 5 is equal to 16. Is 16 less than 16? No, it's not. So putting a bar here or letting it equal that would be a wrong thing to do. Pick a number that's greater than negative 10.5, like negative 9. Well, negative 9, if you substitute in, you get positive 18, and positive 18 minus 5 is positive 13. Is that less than 16? It is. So any number that's bigger than negative 10.5. Notice the checking here helps me if I accidentally don't flip this sign, like I almost did there. If I wouldn't have flipped that sign, it would have been x is less than negative 10.5. So you pick a number less than negative 10.5, like negative 12. So if I'm checking my work, I'd get a positive 24 minus a 5, which gives me positive 19, which is not less than 16. So you have to flip the sign, and if you check, that will keep you from making the silly mistake of not flipping that sign. This one, you subtract 1 from both sides, a is less than or equal to 90. All right. I'm just going to kind of roll through these so we get on with the lesson. Add 10 to both sides. I get negative 4z is less than negative 2. So z must be greater than positive 1/2. Notice how I flipped the sign there. Number 9, subtract 3 from both sides. You get 6n is less than or equal to negative 24. Divide by positive 6, you get n is less than or equal to negative 4. This one I can combine like terms right here off the bat, and I get negative 2x plus 2 is less than 12, or negative 2x is less than 10. So x must be greater than negative 5. I divided both sides by negative 2 here, so you flip the sign. Do the distributive property here. Since you've got those parentheses, you get negative 12x plus 3 is greater than or equal to 15. So negative 12x is greater than, oh, don't forget the x, is greater than or equal to positive 12. So x must be less than or equal to negative 1. Flip the sign because we're dividing by negative 12 at the end. Once again, I'm going to combine my like terms. I got x and 8x. That gives me 9x's. Minus 4 is greater than negative 76. Add 4 to both sides, and 9x must be greater than negative 72. Divide by 9, you get x is greater than negative 8. And the last one in the warm-up, subtract 78 from both sides. X must be greater than or equal to, let's see, kind of hard to do that one in your head, but some people can. I just don't want to make a mistake while I'm recording. I get negative 362. All right. So that's the warm-up. Remember, we're talking about inequalities here, and we're going to see some inequalities when we deal with triangles. And so this is just algebra review before we start our geometry work. So this is inequalities in one triangle here. And I want you to look at this and think to yourself, when we see this triangle ABC here, which side is the largest, and why do you think it's the largest? So if you said it's the largest because AC here is the largest side because it looks the largest, I want you to do better than that, because we don't want to go by looks, because sometimes I can draw the triangle all out of whack, and I might make this side appear to be the largest. I might just be bad at drawing. BC may not be the largest, but may appear to be the largest. The reason why AC is the largest side is because it's across from the biggest angle. And so that brings us to a rule with triangles, that the biggest side is always across from the biggest angle. And likewise, the smallest side, which side do you think is the smallest? Going by looks here, it almost looks like BC and AB are the same length, but they're not. Because when we talked about isosceles triangles, remember, if this is equal to this, then the base angles 20 and angle C down here would be the same. They're not. So the smallest side is always across from the smallest angle. So 10 is the smallest angle. That means AB must be the smallest side in the triangle. And then BC is the mediumest side because it's across from the mediumest angle. Yes, that's a word. Mediumest. Now look at this one. This is kind of reversing it. Which angle is the largest here? So if you said angle B, you're correct, but also make sure you have your reasoning correct. What's the reason? It's not because it looks like the biggest or because it's a right angle. In fact, we don't know if it's a right angle unless we do some Pythagorean theorem here to check it. But the reason why we know B is the largest angle is because it's across from the largest side. So the largest side will tell you where the largest angle is across from it. Also, we can find the smallest angle. The smallest angle will be across from the smallest side. 18 is the smallest side, and so C is going to be the smallest angle. And this is when we're comparing sides and angles within the same triangle. We're not taking two different triangles and trying to compare their sides and the angles. It doesn't quite translate to two triangles. Now, for a little bit of recall, we talked about remote interior angles, I think, a couple chapters ago. And we said that angle 4 is equal to the sum of, in this case, angle 1 plus angle 3. And we proved that. And we proved it in the last chapter by saying, hey, angle 2 plus angle 4 equals what? Well, it equals 180 because they're a linear pair. And then you know angle 1 plus angle 2 plus angle 3. Actually, let me rewrite this a different way so the proof comes out a little bit better. Angle 1 plus angle 3 plus angle 2 equals 180 degrees. So I know that angle 2 plus angle 4 equals 180. And I know that angle 2 plus 1 and 3 add up to 180. So I can even rewrite these and say that angle 4 is equal to 180 minus angle 2. If you subtract angle 2 from both sides. And then I can say angle 1 plus angle 3 equals 180 degrees minus angle 2. So notice what I'm getting at here. This mess is the same as this mess. So since 1 and 3 add up to this, and so does angle 4 equals this, angle 4 must equal the sum of 1 and 3. And so we call angle 1 and 3 the remote interior angles to angle 4. Or in other words, they're not the ones that are right next to or adjacent to angle 4. So now we can start using that. I want you to compare a few things here. Is angle 5 greater than angle 1? And is angle 4 greater than angle 3? So think about that for a moment. I'm going to grab the highlighter here. I want you to note something. If I take this triangle, that's a bad highlight job there. Let's see. Now, just like on the previous page, we have angle 4, that's the exterior angle. I know that 4 is the same as whatever the measure of angle 1 and 3 are. Add it up, you'll get angle 4. But notice 4 and 5 are vertical. So think about that. So first of all, is angle 4 greater than angle 1? Well, we can pretty much say yes, it has to be. And the reason why is I know that you have to add angle 3 to angle 1 to get angle 4. So I know that 4 must be greater than angle 1. And since 4 and 5 are vertical, 5 must also be greater than angle 1 because I know 4 and 5 are congruent. You can also say that 5 is the exterior angle to the triangle, and so 5 must be the sum of 1 and 3 as well. So if you kind of cover this section up, 5 is an exterior angle to the triangle, and so the remote interior angles are still 1 and 3. They add up to angle 5. Next, is 4 greater than angle 3? Well, yes, same reasoning here, because you have to add angle 1 to angle 3 to get to angle 4. So 4 must be greater there. So we're making our diagrams a little bit more complicated now. Question is 7 greater than angle 4? So notice on this one, we can say that 4 is still greater than 1, it's still greater than 3. Also note that they give us the lines are parallel. So if that helps you, highlight these parallel lines. And remember, anytime we have parallel lines, we should be thinking, maybe we've got the star smiley guide going on here. And so you got two transversals that are possible here. I'm going to focus on this transversal going straight up and down. What kind of angles are 1 and 7 here? Well, 1 and 7 are alternate interior angles, and we know that if the lines are parallel, then alternate interior angles must be congruent. So if we look back at that, is angle 4 bigger than angle 1? It is, because 1 and 3 add up to give you 4. And since 1 is congruent to 7, If 4 is bigger than 1, it must also be congruent to 7 because they're the same measure. So is 7 greater than angle 4? No, it's not. Let's do some practice with listing the order of the sides from largest to smallest here. So take a moment and list these in order, like is AB the biggest, is AC the biggest? So I want it from biggest to smallest. List those out, please. All right, so I take it you've paused it, given it a try. Now, some students get this right off the bat, sometimes they don't. And they're like, how do I figure out what x is? You don't have to figure out what x is. You can give me any value you want for x. Suppose x equaled 5. Which side would be the biggest? Well, AB would. And then AC would be the second biggest, and this would be the smallest. Here's a case where AC looks to be the largest, but we don't go by looks. I don't care what you give me for x here. Any value for x, we know that x must be larger than 1, because if it's 1 or less than 1, you're going to get a negative or a 0 length here for BC, and we don't have a triangle. But you give me any value for x, the largest side is going to be the one that you're adding the most to. So AB must be the largest side because you're adding 3 to it. You're not adding 3 to any other side there. The next largest is going to be adding 1 to it, so that's going to be AC. That's the mediumest side. And then the smallest side is the one you're subtracting 1 from. That's going to give you your smallest value, which is BC. All right, let's try the next one. The next one's going to take us to possible lengths of a triangle. So I'm going to switch it over to my camera mode here and kind of show you what I normally do with students in class. So here's what I have. I've got 2 straws here, and sometimes I'll do this with, actually most of the time I do it with some pasta. I'll give each student 2 pieces of pasta and tell them to make it the same length, 2 pieces. Here I've got straws, so we know they come manufactured pretty much the exact same length. And I'm going to take one of the straws, I'm going to cut it anywhere I want on this straw. It doesn't have to be in the exact middle, it could be anywhere like this. Just cut it right there. And so now I have 3 pieces. And the whole idea is to make a triangle with these 3 pieces. And when I say make a triangle, I don't mean like this. See where I have some extra links there. I want it stacked end to end. And so when I try to stack it like this, well, they're too far apart, so I have to change the angle up some. And so the whole idea is I want to take it like this, where they're like being nailed right at the end, kind of pretend like it's a board, and lower these angles until they get closer and closer and closer to reaching. So you can see it on the screen here. So as I roll these closer and closer and closer to each other, there's the angle still matching up right there. They're almost reaching right now to make it. But as they get closer and closer and closer, they never do quite reach. You can try this yourself at home. Sometimes the angles right here don't quite match up, but notice they don't reach until they're right on top of each other like that, and I don't have a triangle. So a few things to note about this. These 2 smaller segments, they add up to equal this side right here. And so when you're trying to draw out a triangle, if these 2 sides add up to equal the 3rd side, it's not a physically possible triangle to make. These 2 sides cannot add up to equal the 3rd side, and you still get a triangle. In fact, when I make quizzes, sometimes I'll say, all right, let me make a quiz, and I need just some numbers for triangles. If I make this, say, 3, 1, and 4, and I'm putting angles in here for students to take the quiz, well, that's not a physically possible triangle to make. If you give me a triangle with 3 inches, a side of 3 inches, a side of 1 inch, a side of 4 inches, you can't put them together and make a triangle because these 2 don't meet up until they're right on top of that 3rd side. Now, to take it one step further, I'm going to take one of these sides right here. I'm going to cut off even more. It doesn't matter where. See, I cut it off right there. Send him away. Now I try to make a triangle. It's going to be even worse because notice they're definitely never going to reach each other here. And so these 2 sides right here, when I add them up, I get them to add up to be less than the 3rd side. So I can't have, suppose if I'm making up a quiz and I make this side 2. This is also not a possible triangle to make because 2 plus 1 is not equal, or it's not equal to 4, but it's less than 4. So they're definitely never they're gonna look kind of like this. They're never going to be able to reach each other. So it's important to note here that they can't add up to equal the third side, and they can't add up to be less than the third side. That must mean that any two sides of a triangle must add up to be longer than this third side in order to form a triangle. Let me say that again. You give me a triangle with side lengths of A, B, and C, then this is what I can say. A plus B, their lengths, must be greater than. Not greater than or equal to, because if they're equal, then they're just going to barely, when you fold them down, they're not going to touch until they're on top of C there. They must be greater than C. Likewise, B plus C. Side length B plus side length C must be greater than the third side A. And then C plus A must be greater than B. We're going to see this as we continue with our notes and homework here. So this is it listed out again if you want to rewrite it. That's what I just wrote on the piece of paper there. You don't need to rewrite it though, but if you want to see it in a different format, that's the exact same thing I just wrote out. So this says you are planting a triangular flower bed and have found 2 boards to frame the garden. What are the possible lengths that you can make the third side? So we're assuming here that you don't have a saw to cut the boards, and you got to go out and buy a new board. What are the possible lengths that you could make that third side here? So this is all going to come down to saying, well, what are we going to label that third side? Let's call it X because, you know, math people love X, right, for their variable. So this side right here is going to be X. If I can draw it out in one swipe. And I know that 5 plus 8 must be greater than X. So that's how I'm going to write out the inequality. This is X. 5 plus 8 must be greater than X. So 5 plus 8 is what? 13? 13 must be greater than X. So let's test that out. If X was, say, 4, is 13 greater than 4? It is. Good. Is 5 plus 8 bigger than 4? Yes, it is. But there's also, so that does work. X could be 4, and that would make a triangle. Could X be 2, though? Well, is 13 bigger than 2? It is. Is 5 plus 8 bigger than 2? It is. But is 2 plus 5, is it bigger than 8? No, it's not. 2 plus 5 is 7. So since 7 is not bigger than 8, this is not a possible triangle. So there's more than one inequality I got to solve here. Not only do I have to say 5 plus 8 must be bigger than this side, but I know that X plus this smallest side given, X plus 5, must be larger than 8. And so now solving for this, I know that X must be greater than 3. So if X were equal to 3, 3 plus 5 is equal to 8, and I can't have that based on what we just saw with the straws there. So it must be anything bigger than 3. So it could be 3.01. 3.01 plus 5 is 8.01, which is bigger than 8, so that works. So my range of possible values for that X is this. I'm going to say X must be less than 13. That's what we got up here. But it has to be bigger than 3. And so this is my answer. Any value between, but not equal to, 3 and 13 are possible triangle lengths with sides 5 and 8. All right, and so that takes us to your homework. I want you to give the homework a try there. Let me know if you have any trouble, and thanks for watching.